Hey everyone, today we're going to talk about building generative AI apps with your own data stored in Azure Cosmos DB. I'm James Codella. I'm a product manager in Azure Cosmos DB, working on all of our AI features. So let's get into it. So we all know that Azure Cosmos DB is the world's most scalable AI database, right? We have a serverless model that allows you to start really cost effectively, but we also have a provision throughput model that allows you to take advantage of things like our auto scale capability. Cosmos DB features automatic sharding and partitioning of your data, so you don't have to worry about if your data scales to very large sizes. We take care of that sharding for you automatically. Cosmos DB also features high elasticity with instant auto scale. So Cosmos DB scales out as your demand increases and then scales back in as your demand decreases. It features low latency with real-time data transactions, under 10 millisecond latency for point reads and writes. We have high availability where you can maintain reliability of 5 nines, which is really world-leading, world-class. It also offers 5 levels of multi-tenancy built into the database, everything from logical separation of your tenants or users at a logical partition level, all the way up to separate containers and databases and resources as well. More recently, we've developed built-in vector indexing and search capabilities in Azure Cosmos DB, which we'll talk about more in depth and see a demo today. And this features DiskANN, which is a new state-of-the-art suite of algorithms developed by Microsoft Research and implemented for the first time in a Microsoft product that you can use yourself. So before we get into the demos, let's talk a little bit about common AI scenarios with Azure Cosmos DB for NoSQL. First is chat history, right? So if you're building a chatbot or using a large language model to build an intelligent agent, you might want to keep track of the chat history between your users and your AI models. You can do this for multiple reasons, and we'll get into that in a little bit. But we have thousands of customers doing this today with Azure Cosmos DB. Next is RAG, or Retrieval Augmented Generation. So this is all about taking the most relevant data from your database and using it to ground or personalize a large language model or a small language model in order for it to really become contextually aware to your scenario and to your data. Next, we have thousands of customers building multi-tenant apps in Cosmos DB. I talked about how multi-tenancy is built into Azure Cosmos DB, and so a lot of customers take advantage of that today in an AI-based scenario. We also have customers building real-time recommendation systems, anomaly detection systems, and multi-agent AI systems as well. These are really exciting things that our customers are developing and continuing to push to production. And of course, we have multiple customers building all these sort of AI applications on Cosmos DB. Maybe most prominently is OpenAI that uses Azure Cosmos DB as the chat history store for ChatGPT. So your conversations that you have with ChatGPT are actually stored in Azure Cosmos DB because of its really low latency for its point reads and for its queries, as well as its scalability. So lots of excitement around Azure Cosmos DB for AI apps and a lot of use cases as well. We'll dig into a couple of the top 3 ones here: chat history, RAG, and multi-tenant apps. So with that in mind, let's talk about some of the use cases for Azure Cosmos DB in GenAI scenarios. First is we have the idea of a vector and operational database, right? So I mentioned that we recently have vector indexing and search in Azure Cosmos DB. So this is really exciting, right? It gives you the opportunity to store your operational data and your vector data together in one data store in one data item, right? This is really exciting. So it removes the need to ETL your vector data from a database to a dedicated vector database, right? You can store your vectors and your data together in one data source in one data item. This allows you to have highly consistent data and reduces the complexity and costs of your AI application infrastructure. Built on top of this vector and operational data store, we can do things like retrieval augmented generation, right? So bringing the most relevant data from your database to ground your large language or small language models. This allows you to personalize your models on your data. It's cheaper than fine-tuning and allows you to quickly iterate on new scenarios, right? And you can do this today in Azure Cosmos DB thanks to our new vector search capabilities, which we'll talk about in a little bit. Additionally, chat history, right? So I mentioned that thousands of customers are doing this today in Cosmos DB, and they're doing this for multiple reasons, right? One is to maintain conversational context. So you want your chatbot or your intelligent agent to remember what was talked about in a previous session or previous day or even last week. But you can also do some mining on the chat history data to identify, where does your large language model perform well, and maybe where does it need a little bit of help? Maybe need some fine tuning, maybe need some prompt engineering or some other improvements as well. Also, chat history is used quite often for auditing, right? If you ever call the customer support line, you may hear this call is recorded for quality purposes. We do this for human-to-human interactions, so it only makes sense that we might want to do this for human and AI interactions as well, right? And then there's this notion of something called semantic caching, right? So the idea of semantic caching is I'm already storing chat history in Cosmos DB. So maybe I can actually take advantage of that in my chat scenario, right? So imagine that I have my chat history consists of a user question and then a response from my large language model. So if I've seen a question, if I see a question multiple times, maybe I can leverage a historical response from my large language model that I'm storing in my database and use that instead of making a call to my large language model API, right? So the idea is I will take the user question and vectorize it, create a vector embedding of it. And then when I see a new user question, I could run a vector similarity search in my database on all my historical data. And if I've seen a very similar question before, I can actually take the historical historical response that I've saved in my database from a large language model previously and surface that to the user instead, right? So the idea is that this could save you cost because oftentimes calling a large language model, like a GPT-4 model, can be very expensive. And also it has high latency, right? It takes sometimes multiple seconds to get a response from a large language model, whereas executing a vector search in Cosmos DB, can take tens or hundreds of milliseconds. So really, really fast, and really, really nice feature here. So here's some of the common use cases for generative AI apps using Azure Cosmos DB. So I mentioned that we launched a couple new vector indexing and search capabilities in Cosmos DB for NoSQL. Primarily, we have these three areas, right? So native vector indexing and search in public preview. So what I mean by native vector indexing and search is that this is actually part of the core database engine itself. It's not a separate service that sits outside the database. It's another thing that you need to provision, right? It's just part of the Cosmos DB engine and database that you get, and you can store your vectors alongside your original data. Next, we announced a DiskANN based vector index. So DiskANN is an advanced vector index that allows you to do highly scalable, efficient, and cost-effective vector search at any scale. And we have this in gated preview today. Next, we launched some AI framework integrations with Semantic Kernel and LangChain, and there's more integrations to come. Let's talk a little bit real quickly about Cosmos DB for NoSQL with this DiskANN-based index. So the idea behind DiskANN is actually relatively simple. So you start with your vector embeddings, and you insert them into your Cosmos DB database. What we do on the back end is we take your vectors and we put it through a compression method called quantization. The compression method then scopes down the size of these vectors to be more efficient to store in RAM. The full uncompressed vectors, along with the graph data structure of DiskANN, is then stored to high-speed SSDs that make up the backbone of Azure Cosmos DB. This interaction between during search between the compressed vectors that are stored in RAM and the uncompressed vectors that are stored on SSD allow the DiskANN index to scale to huge sizes very efficiently, right? So we use very little computational resources and RAM, because RAM is actually quite a lot more expensive than SSDs. And then we leverage the scale-out architecture of Cosmos DB and the high-speed SSDs to store the full vectors and graph there. And DiskANN, as I mentioned, is a state-of-the-art suite of vector indexing algorithms developed at Microsoft Research, and we're bringing it to you for the first time in a Microsoft product. And you can take advantage of everything that Cosmos DB is built on, right? The unlimited scale, low latency, And DiskANN in itself is a robust to data changes, and it works with both our serverless model and our provision throughput model. So we're really excited about the potential for high scale, high efficiency, high accuracy search with Azure Cosmos DB and DiskANN. All right, so I talked a lot already. Let's get into some demos, right? So what we're going to do today is I'm going to walk through some code on building an assistant powered by your data in Azure Cosmos DB. So we're going to build a highly scalable multi-tenant generative AI chat app using Azure Cosmos DB for NoSQL. We'll implement a RAG pattern using vector search in Azure Cosmos DB for NoSQL on your data. And we're going to be using Azure Cosmos DB for primarily three things. One is to manage chat history. Two is to store and retrieve data for RAG with vector search. And three is the semantic cache that we had talked about as well. And so we're going to do this. There's a great GitHub repository I'll show you in a minute that has a great template that you can use. So we'll store things in Azure Cosmos DB here. We'll leverage Azure App Service to deploy our application. And then we'll also leverage the Azure OpenAI service. And we'll do this for creating our vector embeddings and for generating our completions or our responses from large language models. All right, cool. So let me switch over here. So this is the GitHub repository that we have. I have some links at the end of this presentation, so you can feel free to hold off, or you can just go and check it out right now. So this is the demo that we're going to walk through, right? So we're going to be building this essentially like a co-pilot-like service here with Azure Cosmos DB. We're going to walk through everything that we had talked about, right? How to build a highly scalable, multi-tenant, and multi-user generative AI application using Azure Cosmos DB for NoSQL. Works basically with these main components that we talked about. And then it also has a really nice user experience. So it's built in using Blazor. So we're going to deploy this Blazor app so you can just access it through the web. And you'll be able to ask some questions about this imaginary bike store, the Cosmic Works bike store. In this example here, it's asking some general trivia questions, but we'll be able to ask other questions that are specific to data that we're storing in Cosmos DB. So let's take a look. All right. So when I deploy this Azure, and actually let me go back a minute here. This is actually really easy to get started, right? It walks you through the prerequisites of what you need. It's how to sign up for the vector search preview, how to configure your Azure OpenAI resource, etc. And then there's instructions how to get started really easily, right? You can use AZD to initialize and download the code from GitHub. You can log into AZD and then do AZD up and deploy the resources, and they'll be all connected for you in Azure. So really, really easy way to get started with this demo quickly. And once you do that, it will deploy a resource group for you. So here's my sample resource group here. And then I can see all my resources that are deployed here, right? So I'm using Azure Cosmos DB here. I have my Azure OpenAI resource here. I have my app service plan here. I have my managed identity here. So I'm maintaining my keys here. So this is really secure. And this is a great example of how to build a secure application. And then I'm using Azure App Service to actually orchestrate my application and actually run my Blazor app, right? And this looks like this. Here's my app. Here's my web app here. And I can actually go ahead and browse this web app, right? So let me click on this. And here I see this web interface, right? So let me actually zoom in here a little bit so it's a little bit more legible. There we go. So I don't have any chats in here, right? So we'll create a new chat session here. Let's go ahead and do that. Create new chat session. Cool. So maybe we'll say something like, hello, my name is James. Can you tell me about bikes that you have? So I just submitted my prompt to Azure OpenAI, and it orchestrated everything, right? So I submitted my prompt, it looked at some chat history. I have no chat history, so I wasn't able to pull anything. But it sent it to Azure OpenAI to generate a completion based on the parameters that we set for our chatbot. So this says, hello, James, I don't sell bikes, but I can provide more information about different types of bikes. And it's giving me some information about different types of bikes. So then maybe I can say, I live in New York City. Can you recommend some bikes that might be good for my commute? And let's see what it comes up with. Cool. And it says, certainly, for commuting in New York City, you want a bike that's durable, right? And so it recommends some bikes, and it's able to understand that I live in a city and I want to commute because it's creating vector embeddings from my prompt, from my message to the large language model. And then executes a vector search in Azure Cosmos DB to find the bikes and to find the products that are most relevant to my question. So this is really cool, really powerful stuff. And I can see that I've created a multi-tenant app here because I can actually create a new chat session. And in this chat session, it's completely brand new. It has no idea what my name is, right? So I can say, hello, what's my name? And it doesn't know my name. It doesn't have access to my personal information, right? So this session information that I just started in this new chat is completely separate, completely isolated from this bike recommendation session here. And I can continue going on here. Tell me more about electric bikes. Oops, electric bikes. There we go. And now it gives me a summary of electric bikes and why I might want to use these, right? So some of the information is from the vector search that was returned by Azure Cosmos DB, and some of it is returned just from the knowledge in the large language model itself. Now watch this. If I copy and paste a prompt that I've already entered, right? So let me enter this in again. I live in New York City. Can you recommend some bikes for my commute? Cool. So did you see how fast that was? That was near instant, right? So what we can see here is when I asked this question originally, I live in New York City. Can you recommend some bikes that might be good for my commute? We stored this in Azure Cosmos DB. We stored my question and the vectorization of the vector embeddings that represent my question. And we stored the response from the large language model in Azure Cosmos DB. So when I asked another question, we first ran a vector search on the data in Azure Cosmos DB, on the chat history, and try to see, was this question asked previously? And since we already logged it in Cosmos DB, we were able to find this question again and surface the information that the chatbot already gave me earlier, right? We're able to leverage this historical information. And we can see in our token counter up here that returning this piece of information from the database actually cost 0 tokens, right? We didn't actually have to call our large language model at all. All we did was execute a vector search and return the last or the most relevant response from the large language model that we've captured historically. So this is an example of a semantic cache, right? It saves me money because I didn't have to call the large language model, and executing a vector search is very cheap. It also saves me latency. As we could see, the response from the assistant was near instant. So really powerful stuff. Go ahead and take a look at the GitHub repository and play around with this. But let's go ahead and look at the code real quickly, and we can see what's going on behind the scenes. Cool. Okay, so let's get started here. So I have my Visual Studio set up here. And here's basically what the Solution Explorer looks like for all these services, right? I have a bunch of different folders, a bunch of different files. We'll go through a couple of the main files here, right? So in the main sort of root directory, I have this azure.yaml file. And this basically just contains all the connection info for my Azure resources, right? My OpenAI endpoints. I'm using semantic kernel here to orchestrate the calls to my embedding model in Azure OpenAI and my completion model or my GPT model. And then I have my Cosmos DB endpoint information and some of my chat parameters. So these are all going to be environment variables, right, that I can set in my web app. So it makes it really easy to customize and to personalize these things once it gets deployed. In the main program itself, this is basically going to build the program for me and build all the services for me. So we're going to make sure that we build my resources. We're going to make sure that we register my Azure Cosmos DB service, that we create the database and the containers for managing my chat history and my semantic cache and all my product data as well. And also all my orchestration, even my orchestration of creating a new semantic kernel service is going to be stored here in the program.cs file. Next, we have an OpenAI services CS file. And this is going to walk through all the connections and interactions with my Azure OpenAI services. So you can see that actually I'm defining some strings here for my completion or my GPT model and my embedding model. But I'm also going to define things like my system prompts, right? So my instructions that I give to the large language model, such that it knows how to behave and knows how to respond to my scenario, right? So this is sort of a general system prompt here. You're an AI assistant. Please provide polite answers. But then we can see that I also have this system prompt retail assistant here. You're an intelligent assistant for the Cosmic Works Bike Company. And this is the one that I just used, right? I want to make this retail assistant personalized to my specific retail shop. So I can give that information here as well. So this OpenAI services contains all the information and all the endpoint information, and even things like my parameters for my large language models here. And you can go and take a look. This is really a great example of how you might want to configure these resources in your own application. And then, of course, we have a helper function here for getting the vector embeddings, right? So if I ask a question and I want to do a vector similarity search and find the products in my database that are most similar to my question, I have to create a vector embedding of my question. I can do that using the Azure OpenAI service. And this code shows you a nice helper function of how to do that. Next, we have a Cosmos DB services.cs file. And so this is really great because this sort of orchestrates all of the operations that I would want to perform in Azure Cosmos DB, right? Everything from getting the database and chat container and cache container and product containers, my product information. So this basically orchestrates connections to all the containers or collections in Cosmos DB. This also orchestrates loading of the product. So in this GitHub repository, we have some sample data that you can automatically load into Cosmos DB. It actually does that for you. That contains product information and vector embeddings. So this function, load product data async, will do that for you. There's also other information as well, like defining a partition key. So we're going to use a partition key builder class here in order to build a partition key that's based on tenant ID, user ID, and session ID. So if you recall, back here in our chatbot, right, in our chat application, we have these different sessions here. So I can maintain session isolation. So what I'm talking about in one chat session doesn't influence the other chat session. But I also have like these different users as well that I can focus on, right? So I have some examples here. They're all PMs on the Cosmos DB team. Mark, James, me, our friends Sandeep and Saji. So you can experiment with just not only different chat sessions, but even like, look at this, different users, right? I just switched users here. So this is James. I was in a Mark user before. And now I see there's no chats available because I didn't start a chat as James, right? But if I go back to Mark, I can see the sessions that it created under the Mark user. So this is really cool and really powerful, right? I'm using Azure Cosmos DB's partition key to have logical separation between not just my sessions, but my users as well. So really cool stuff. And there's some examples here of how to get started. Now we can also see some other helper functions too that help me get some partition key information or get session information. There's an example query here for how to get the most recent messages from a session. And then we can even see an example if we scroll down far enough. Here's an example of a vector search in Cosmos DB, right? So this is just a query. It's actually a query with a subquery. And I'm just selecting, my top results, and I'm projecting a couple different pieces of information about my data, maybe a category name and SKU and name and description of products. And then I'm executing a vector search, right? So I'm using this vector distance system function, and I'm basically doing a vector similarity search between my vectors and my query vector, right? So s.vectors would be the vector representation of my products. And this at vectors is just a parameterization of my query vector, right? So if I say, hey, tell me about bikes that are useful for me, I live in New York City, we're going to vectorize that and pass it through here as that parameter. That's what that at vectors is. So you can see a nice example here of executing a vector search in Azure Cosmos DB NoSQL, which is really, really easy and straightforward. Next, we have a chat services.cs file. And again, this just orchestrates the different interactions between the database and semantic kernel and your Azure OpenAI service, right? So your orchestration of hey, I want to make sure I get all the chat messages from this session. And I want to make sure that I'm getting the most recent chat session information to feed it to the large language model for contextual awareness. And then this get cache async is a search to the semantic cache, right? So we can actually look at this. I go peek at definition. I can see here that this is actually running the get cache async here. And what this is doing is essentially it's running a vector similarity search on all my cached conversations. So all the questions I've asked or all the prompts I've sent to as a user to the large language model and all the responses from the large language model. So this leverages the semantic cache, and we'll see if there's any results in the semantic cache. We'll see if my question or my prompt has been asked before or given before to the model. And if it hasn't, the response is going to be empty. And so then I'll cache this response, and then I'll return the chat message. So this gives you a really nice comprehensive walkthrough of maintaining session information and user ID information between each session, leveraging the semantic cache in Azure Cosmos DB, doing a vector similarity search amongst all my product data stored in Azure Cosmos DB, and then feeding all of that to the large language model in order for it to generate a response that's personalized on my data, it's personalized to my user's question. And then, of course, I have a semantic kernel service file here that basically just orchestrates everything that we saw using semantic kernel. So basically generating the embeddings and generating the completions from Azure OpenAI. So that's about it for the code, right? There's some other files in here for configurations. You're more than welcome to go through and clone the repository and walk through it yourself. The last thing I'll show you is what this looks like in Azure Cosmos DB itself. So let me close this so I can just start from scratch here. So what I have here is this is my resource, my Cosmos DB resource that got deployed for my AZD up command. So this is the one that gets provisioned and loaded with data in Azure Cosmos DB, just using that this Copilot demo code that we've provided for you. So I can see that it's instantiated as Cosmos Copilot DB database, and I can see I have multiple different collections here. If I take a look at the products catalog, I can go to items, and I can see that there's a bunch of different items from my bike store here, right? I can see an ID, a category name, a description. So this is like a seat or a saddle. And I can see a price associated with it. And if I scroll down, I can see the vectors, right? So these are vector embeddings that are created using one of the Azure OpenAI embedding models. And they're just, it's just a list or an array of floating point numbers, right? So this can be stored as just another property in Azure Cosmos DB, right? And this is part of the value prop that we're talking about here. I don't need to store my vectors in a dedicated vector database somewhere else, right? I don't need to maintain another service. I can store everything in Cosmos DB, and I can have my vectors just as another property of my data items. So this is really, really powerful stuff here. And as I go through some examples, I can see other items as well. Like here's a bicycle, it's a touring bike, and I can see the vectors here as well. I can see other collections or containers that were created for me as well, right? So I can see, here's my chat container. So this is all of the chat history, right? So I can see that I've created a session using this mark character, and I can see, right? So remember at the beginning where I entered in, hello, my name is James. Can you recommend me? Can you tell me about some bikes that you have? Here's that prompt. We're storing this info in Cosmos DB. All the code to do it is in the GitHub repository. And we can see, the completion. This is what the large language model, this is what my OpenAI GPT model responded to me. And I can see some other statistics here about usage. So cool, like I can see my chat history. I can even see the semantic cache information that's stored in the cache container, right? So I can see what that looks like. So I can see that for this ID that's associated with, that chat history item, I can see the vector embeddings that describe it. So this is basically for the, for the chat history that I have, I can see the relevant information and the vectors that represent that, right? So I can see, so here's an example of the vectors. This is the item. When I said, I live in New York City, can you recommend some bikes that are good for my commute? And this is what the large language model responded. I'm storing this in Cosmos DB. So if I see this question again in my chat app, I can just do a vector search on this vector, and the user's prompt, find this information because I've already asked the question before, and then just leverage this, right? If we go back to the chat app, we can see, certainly for community in New York City, this is exactly what was responded here, right? So we're just pulling that from Cosmos DB and leveraging what we've already seen. So we've walked through a couple of great things here today. We talked a little bit about Azure Cosmos DB. We talked a little bit about some of our vector search scenarios and capabilities in Azure Cosmos DB. And then finally, we walked through a GitHub repository that has information and some code to get you started with this example. So before we leave today, I'll offer you a couple of resources, the next step links that you can get started with. The first is to learn more about Azure Cosmos DB for NoSQL vector search with this overview page and our documentation. The next is if you want to use our DiskANN advanced, highly scalable, highly efficient vector index, you can go ahead and sign up for the gated preview following this link. Next, we have our announcement blog post where you can get even more information about Azure Cosmos DB and DiskANN. Finally, you can check out this link for our Cosmos AI samples repository. This contains a link to all of the Azure Cosmos DB AI samples that our product team has created, and it can get you started in .NET. We even have some Python examples for those of you who might be inclined to take a look at that. And then finally, if you want to take a look at today's demo, you can follow this final link down here, aka.ms/cosmosdb-nosql-copilot, and you can get started really easily. So that's it for today. Thanks for joining me to learn more about Azure Cosmos DB and our AI capabilities.